Okay, so we're in this polynomials unit, but I want to make sure that we're all on the same page of what a polynomial is. So polynomial comes from the word poly and nomial, poly meaning many, and nomial meaning either numbers or terms. We'll talk about what a term is in a minute. But first, I want to talk about some examples. Polynomial is basically just any set of numbers that are connected by either addition, subtraction, multiplication. We could have like x squared plus 2x plus 3. We could have 5x plus 1, just x to the fifth, negative x plus 3, pi x squared, look at that pi. 3 minus x squared divided by 3, 2x plus or minus the square root of 3. Hey, negative 7, guess what? That's a polynomial. And even something so crazy like 3x to the fourth plus the cube root of 4 all over 81. Okay, all of those are examples of what is a polynomial. And I've got some non-examples too. Okay? I want you to notice the things that make these not polynomials. Okay. 5 to the power of x. It's not a polynomial because the variable is in the exponent. Okay? To have an exponent and it still be a polynomial, you have to have it raised to a constant power, like x squared. Okay? Can't have a variable in the exponent. You also cannot have a negative exponent. Alright, so anything to the negative something power, like x to the negative 2 power, not good, not a polynomial. 3 over x squared, dividing by the variable. Anytime the variable's on the bottom of a fraction, like down here as well, can't do it. That's actually why these are not polynomials, because remember, x to the negative 2 power is just 1 over x squared. Okay, x squared's on the bottom. The reason we have such a strict definition of what a polynomial is because it helps us to do polynomial arithmetic like addition, subtraction, multiplication. Okay? I keep not saying division because you can divide polynomials. It's just sometimes your answer when you divide will not be a polynomial. Like we divided polynomials earlier last week and we got answers like this, right? We could divide a polynomial by a binomial, but this answer, whenever you have a remainder, not a polynomial. Okay? Let's get some more vocabulary in. A monomial just has one term. Okay? A lot of people don't think of things like 2x cubed. That is a term. A lot of people don't think of these things as polynomials. And really, I mean, like, they are because they fit the definition, but they're not because there's not that much, you know? But it still counts. Binomial. Bi means two. Two terms. Notice the terms are separated by addition or subtraction. Trinomial, 3 terms. Something like this. And notice, even though it says trinomial in 3 terms, it doesn't have to just be x to the 3rd power. It can be x to the 5th power or x to the 5,000th power. It just has to have only 3 terms. And polynomial, we just use that for 4 or more. A term is just any collection of numbers multiplied by variables, variables raised to exponents, whatever, separated by addition or subtraction. Okay? So, right here, this is a trinomial, and I know you're thinking that fraction there kind of makes it scary, but it's x over 3, not 3 over x. As long as it's x over something, and this is not another variable on the bottom, you're good. It's a polynomial. Okay? These 3 things are terms. You might also hear the phrase leading coefficient. That would be E5. You might hear the phrase degree. That would be the biggest exponent. Okay, and that's only true. The degree is only the highest exponent whenever you're looking at it in standard form, which is like this, where it's separated by addition and subtraction. Okay? If it's in factored form, you've just got to add up all the exponents. Okay? Leading term, that one. Standard form also has them in order of the powers of the exponent, so 4, then 2, then x to the 1st power. Okay? If it's out of order, it's still polynomial, but it's not in standard form. The solutions to a polynomial are where the graph crosses the x-axis. Okay? Where it crosses the x-axis. In other words, what values of x make f of x equal 0? Okay? And I wrote this in red in all capital letters, so it must be important. And it's called the fundamental theorem of algebra. This thing is important, y'all. Okay? It's also one of your definitions for your next glossary. So, the theorem is a polynomial of n degree n, has, how many solutions do you think it has? This tells you how many solutions any polynomial has if you know its degree. Well, if a polynomial is degree 5, guess how many solutions it has? 5. If it's degree 7, it has 7 solutions. If it's degree n, it has n solutions. Basically, the number of solutions a polynomial has matches the degree it is. Okay? That's why whenever you solve quadratics in Math 1 and Math 2, you got 2 answers. And whenever we solve cubics in Math 3, we get 3 answers. Okay? So let's look at the types of solution sets you could have for each type. Going back up to quadratics, which are degree 2. You could have a quadratic that has 2 real solutions. That means that it crosses the x-axis twice, like that. Now, it doesn't all have to be on the negative part. It could be a negative and a positive. Also, this could be an upside-down parabola. Yeah, still cross the x-axis twice. You could have one real double root. In other words, that root has a multiplicity of 2. Okay? And what that looks like is the graph bounces off the x-axis. And it could bounce off from below as well. Okay? And it could have 2 imaginary roots or complex roots, depending on how the equation works itself out. Okay? If it has imaginary or complex roots, guess what? It is not crossing the x-axis at all. Okay? Notice there's no way for it to have one real root and one imaginary root. We'll talk about that in a minute. Cubics are degree 3 polynomials. Okay? You could have 3 distinct real roots, where it goes through the x-axis 3 times. You could have 2 distinct roots, but they're both real, but one of them's a double root. So this is like that multiplicity thing, right? It's going to go through the x-axis once, but then bounce off the x-axis the next time. Okay? This is the one root. This is the other double root, where it bounced. Okay? One distinct triple root. That's the multiplicity of 3. We've been calling that a squiggly swervy line. It kind of comes up to the side, teeters off, and then picks back up. That point right there where it crosses and it did that weird squiggly swervy thing, that's the distinct triple root. Okay, and it could have 1 real root and 2 complex roots. What that looks like is it crosses through the x-axis once, straight through, and then all cubics are going to have to turn around and kind of turn back, but look, it's not going to turn and go far enough down to cross the x-axis another time, okay? But there are still 3 numbers that will make this equation, whatever it is, equal 0. One of them is a real number, and 2 of them are complex numbers. Okay? Quartics, that's a degree 4 polynomial, a quartic. Okay, there's a bunch of different types of solution sets we could have, okay? We could have 4 distinct real roots where it just crosses the x-axis 4 times. We could have 3 distinct roots where one of them's a double root, okay? 3 plus 1 is 3 roots, but one of them's a double, so you've got 3 roots here. Here's 2, and the third one bounces off the x-axis. Okay? And that bounce could have been anywhere. It doesn't have to be just the last root. It could have been the middle root, the first root, whatever. Okay? You have 1, 2, 3, 4. That one where it bounced counts as 2 roots. You could have two distinct roots where they're both double roots. That's where it kind of just bounces and bounces again. You could have two real roots and two imaginary roots. That's where it's going to go through twice, but then it's got to turn around again, but just like that cubic up there, doesn't actually turn around far enough. Okay? Now look at this. It says one real, two imaginary. Now you're thinking, one real and two imaginary makes three solutions, but only if that one real root is a double root. So something like this. A bounce, and then a turn, but doesn't cross. And for imaginary just means it never crosses the x-axis. Okay? Now, if you've noticed, I've only ever written complex or imaginary in even numbers. Okay? Two imaginary complex solutions. One real, two complex solutions. Two imaginary or complex. Two imaginary complex. Four imaginary or complex. Okay? Complex numbers come in pairs. Pairs. Okay? There is no way you can have one complex root and only one. If you've got one, you have to have two. And they're called complex conjugates, meaning if you have one complex root in the form of a plus bi, like let's say 5 plus 7i, where I is that imaginary number, okay, then your other root, you don't even have to do the math, you know that it has to be a minus bi. Okay? A plus bi, a minus bi. Those are called complex conjugates. Thank you for watching. If you have any questions, be sure to email me or ask in class. Thank you so much. Have a good day.